So today we will see types of constraint motion. Types of constraint. There are three types of constraint motion. One is completely constrained motion. Completely constrained motion. Second is incompletely constrained motion. Incompletely constrained motion. And third is successfully constrained motion. Successfully constrained motion. So there are three types of motion. One is completely, incompletely, and successfully constrained motion. So let's start with the first one, that is completely constrained motion. When motion between two elements of pair is in definite direction irrespective of the direction of force applied. Direction of force applied is known as completely constrained motion. Okay, so what does it mean? It means that whenever there is a pair, so I will show one example over here. There is one prism. This prism has one more prism inside it. This is one prism, and inside this there is one more prism. Okay, right. So this prism, which is inside prism, and this is outer prism. Okay, so these two prisms are there. So whatever may be the direction of force of application, either it will be in vertical direction or in any other direction, whatever may be the direction of force, this inside prism or inner prism will move in reciprocating manner inside the outer prism. So this is completely constrained motion. This is your link number 1 and this will be your link number 2. Okay, so when motion between two elements of a pair, so pair consists of two elements or two links in definite direction irrespective of the direction of force applied. So whatever may be the direction of force, this prism will move only in a reciprocating manner. Okay, so this is a completely constrained motion. Link 1 and 2. We will see one more example of a cylinder. There is one cylinder, okay, hollow cylinder, and inside this hollow cylinder there is one more shaft. Okay, this is a shaft. Now this shaft is having collar. So this is your outer cylinder, okay, hollow cylinder, and this is nothing but the shaft. Okay, and this shaft is having a collar over here. Okay, when this shaft rotates, this shaft can only rotate either in clockwise or anti-clockwise direction. So definite direction is in definite motion is in definite direction, either clockwise or anti-clockwise. Okay, whatever may be the direction of force, if I apply the force either in this direction or force in vertical direction, whatever may be the direction of force, this shaft will only rotate. Okay, so this is nothing but a completely constrained motion. Let's go for incompletely constrained motion. So incompletely constrained motion. Incompletely constrained motion. So what is the incomplete constrained motion? When motion between two elements when motion between two elements of pair is possible in more than one direction and depends on direction of force applied. Depends on direction of force applied. applied is known as incompletely constrained motion. Is known as incompletely constrained motion. Incompletely constrained motion. Okay. For example, we will see there is a again hollow cylinder. Okay. This is a hollow cylinder. Inside this hollow cylinder, a shaft is inserted. A shaft is inserted. Now you can now see here there is no collar. When collar is not provided, okay, this shaft will move in a reciprocating manner also. That means it can move in horizontal direction as well as it can rotate in clockwise and anti-clockwise. So when the motion between two elements of pair is possible in more than one direction. So there are two directions now. That is horizontal and rotary motion, and depends on direction of force. So if I apply the force of direction of force over here, then motion will get changed, right? Motion will get changed. So this is nothing but it is dependent on the force applied. So that's why it is known as incompletely constrained motion. Okay, so in this case there are two dependent motions are there, independent motions are there. That is one is reciprocating and second one is rotary motion. Next, successfully constrained motion. Successfully constrained motion. Now let's see the example of successfully constrained motion. Successfully constrained motion means, suppose we'll take the example of footstep bearing. Okay, if we take the example of footstep bearing, okay, so this is nothing but a footstep bearing. Inside this bearing there is a shaft. Inside this bearing, what is there? There is a shaft. Okay, so I will draw a shaft now. Now if we see this bearing, this is a shaft, okay, and this is the bearing, footstep bearing. Okay, this is the bearing, okay. Now when this shaft is moving freely inside this bearing, so it can move up and down. Okay, similarly it will revolve about the axis in circular way. Okay, so this is nothing but the directions, two directions are there. Now in successfully constrained motion, what we are doing, okay, so if there are two possible movements, then one, it can be converted into one movement only by applying some external force or by some external means. So if I apply the force in this direction, what will happen? The direction which is vertical, that is reciprocating motion, will be restrained. Reciprocating motion will be restrained. It can only revolve then. Okay, if I apply the force in vertical down direction, so this motion will get restrained. Only it will revolve in circular way. Okay, so this is successfully constrained motion. Then how we can define it? When motion between two elements, when motion between two elements of pair is, when motion between two elements of pair is more than is in more than is in more than one direction, is in more than one direction, but it is made to have motion, but it is made to have motion, but it is made to have motion only in one direction, only in one direction, only in one direction, by using some external means, by using some external means, by using some external means. It is known as successfully constrained motion. It is a successfully constrained motion. Next lecture we will see the concept of rigid and resistant body.